Our next presenter is Emil Eidin from the University of Wyoming in the US, talking about applying modeling to make informed decisions about socio-scientific issues. Emil?
Okay, hi there. Hope you all can hear me. Um, okay, just a sec. Okay. Hi there. So as said, my name is Emil Eidin. I'm a assistant professor at University of Wyoming at the School of Teacher Education, and I'm going to present to you a work in progress about utilizing computational models, Sage Modeler, which Tom already mentioned, to make informed decisions about social scientific issues. So I guess in a way it somewhat links to our keynote speaker at the beginning, and I want to present, if some of you are not familiar with what are social scientific issues, so briefly to present you some of the characteristics of socio-scientific issues. So socio-scientific issues are controversial, ill-structured, contemporary issues regarding kind of the interface between science and social aspects. They are multidisciplinary and they include ethical tension. And most of all, if some of you are familiar with perhaps making sense of a phenomena and a driving question, so what drives a social scientific issue would be a call for an action. Okay, you can make the analogy to a driving question. That's what, and in social scientific issues, and if we are talking about the three-dimensional framework, if we are talking about, oh, we are looking to make a sense of a phenomenon. So in social scientific issues, we are looking to make informed decisions. So if that analogy helps somehow to understand what are social scientific issues with some, I would say, more familiar aspects, at least in science education. Some examples about social scientific issues and how you present those to students in the classroom. So this is from the a very controversial issue from where I live about the reintroduction of wolves into Yellowstone. If you don't know, so 30 years ago, wolves have been reintroduced to Yellowstone after completely being extinct in the beginning of the 20th century from the area. Uh, and people in Wyoming, some of them are not very happy about that. Other issues, for example, should we ban fracking? Should we tax obesogenic foods? And so on and so forth. Those are just some examples and give you kind of a taste of how you um, actually I would say, present or word the call for an action. Okay. So some of the goals of engaging students in social scientific issues. So first of all is problem solving skills, identifying dilemma, identifying pros and cons and trade-offs, and certain dilemmas and issues. Think how science and government are connected, meaning kind of in the context of science, removing science as this fact-based or very pure, uh, uh, highly cognitive dependent enterprise, but more framing it as it actually is, as an social enterprise that has somewhat some dependent on a government and different stakeholders other than scientists on how it operates. And it has its own biases and so forth. Engaging students and motivating students. So this is kind of based on previous research that shows that engaging students in SSI increases their motivation and positive attitudes towards science. And for students, it's also part of gathering evidence to look at conflicting viewpoints and discuss about those conflicting viewpoints in a respectful manner. Um, and as such, kind of leveraging, I would say, uh, a more efficient environment for dialogic argumentation. And last but not least is action or a plan for an action plan or an activism. And as such, I would encourage you to think about socio-scientific issues or integrating socio-scientific issues as a spectrum. So that and what at the end of one spectrum would be an action plan or a call for an activism. So that would look like um, uh, a class doing a social scientific issue, and they are kind of reaching out to a plan that a plant in their area that is polluting the water and advertising that in the newspapers or you know kind of writing an opinion um, column for the local newspaper. That would be perhaps in the end, or even going to protest. That would be on one end of the spectrum, and I think it's not fair to ask such a thing from all teachers, as you are going to lose many on the way. Uh, on the other end of the spectrum is just something very simple, just discussing about a social scientific issue that is very remote from the community, not very related to the students in a certain area. So I would like you to, I suggest thinking about SSI and the implementation of it in the science classroom as a spectrum rather than kind of a binary all or nothing, because I know there are calls for looking at SSI from this kind of perspective. And I personally think, at least also in Wyoming and other, at least states in the US, but perhaps in other places in the world, that you are going to lose a lot of teachers if you are just pushing for activism. And of course, we can debate about it later. Now, how I know this is a conference about systems thinking, and I did not mention it so far. So, how this is related, all of this is related to systems thinking in the first place. So, uh, the as we said, the social scientific issues is about the main goal is to support students in making informed decisions. And but it begs the question, okay, how do I measure an informed decision? How do I evaluate an informed decision? And for that, I'm basing what I think is very useful framework uh, by Sadler and colleagues, identifying five components of socio-scientific issues reasoning, or like how we reason about socio-scientific issues to make informed decisions. And I'm not going to elaborate on all the five. I just want to mention complexity. And there is a problem with measuring complexity, and I think it's akin to measuring, I would say, critical thinking. Anyone in this room, I think, ha perhaps can recognize critical thinking when they see that, but I think there are various perspectives of how what is it and how how can it operationalized in the classroom. And I think complexity is kind of akin to that in the sense that it's kind of vague, blurry, and you just throw it as a buzzword, and this is not enough, I think. And the idea is to take this complexity issue and take it, oh, let's take a system thinking lens to measure complexity. Let's take it as because complexity, at least in the context of social scientific issues, is very vague. It's not enough, to say the least. So that's so we thought about that, and here's just an example how system thinking lens can be connected to social scientific issues. So when we are talking about interconnected relationships, so in the social scientific issues context, we can think about relationships of power and interest between different stakeholders, how those sometimes conflict or perhaps overlap. When we think about thinking in terms of change over time, right, the dynamic changing, so this is would be come to practice when one would try to predict the possible dynamics that might follow after following a certain decision or a certain policy. When we think about feedback and circular mechanisms, okay, because we have so many stakeholders, because we have so many aspects in the game, uh, one would like to identify nonlinear mechanisms that follow a decision. And of course, that's what makes social scientific issues so complex because you have this aspect, this big aspect hovering of uncertainty, hovering above you of uncertainty. Okay, you don't know for certain what might come from a certain policy and a certain course of action that you are going to take. And as such, emergent behavior, you need to predict in a way emergent behavior, although you are lacking the data to predict that. But it's something you want to consider. What are the what might be some emergent behaviors that come out from a certain decisions, and those are just an examples of how those can overlap with the goals of social scientific issues. And what basically I'm interested in is about operationalizing systems thinking in the context of SSI. So this is great theory. I can back it up in some literature, and it's all fantastic. And working on an article, but it's all theory, and I'm personally I'm less interested in that. I'm more interested in how that kind of looks like in the classroom, and how it can look like in the classroom. And what I'm asking is to what extent constructing computational modeling to support students in making informed decisions. And a spoiler, I'm not going to answer that yet. But what I'm going to do is it's the project is a design-based project, okay? And I created a conjecture map as a you know as anyone who does design-based research is about to do. I won't go through it, but teachers are the key, okay? And to do that, and in my experience, and especially in the context where I'm working in Wyoming, you cannot go over the heads of teachers and impose a certain unit and idea on them. It just won't work. So the idea was to co-design an SSI unit with some teachers in Wyoming. And so luckily, five teachers from two rural towns accepted to participate. When we talk about rural, I know rural is, for some, it's a contentious term, but just give you an understanding of the rurality of Wyoming. Wyoming is 253,600 square kilometers in size, a little larger as a state, a little larger than the UK, and it has uh, about 500,000 residents. That's it. The towns that I'm working with, the one is uh, roughly 6,500 people, and the other one is 10,000 people. Okay, that's the number of people who live in those towns. So two teachers from one town, two chemistry teachers, and three biology teachers. So luckily, I also have this kind of a variety in disciplines. The professional development took for 20 hour professional 20 hours, sorry, and we haven't implemented it yet. So we have the unit, the teachers designed the unit, but implementation is going to happen actually in about 2 weeks. So I'm going to talk with you about the design. The professional development design, what we did is like going through SSI foundations, talking about Sage Modeler, all the technicalities of the modeling tool, which went pretty well, I must say, surprisingly. Um, the teacher chose an SSI. They analyzed SSI to its scientific components and social components, and they aligned concept with NGSS and Wyoming standards. We knew that because we wouldn't get the approval from the principal of those schools if those weren't aligned with Wyoming standards. Something I know there's this contention between how you navigate between public, private, and so on, and how you kind of move yourself into the system. So I think, yeah, you need to find some of the compromises there. Teachers build a target model, which I'll share with you, and they added SSI components to the model, and eventually they wrote the unit. Um, Both groups they have a full had a full agency, but both groups focused on CRISPR and how as a context for an SSI. And again, if you know a little bit about Wyoming, it's a it's a rich state with a lot of oil and gas resources, and anything that is to do with climate change, with fracking, or those resources is highly contentious, and teachers just didn't want to go there. Okay, there is a lot of teachers are kind of find themselves uh, between a rock and a hard place when it comes to that. And all of them were, although enthusiastic, very reluctant about SSI because the contentious component it has in it. So also they are very kind of I would mention brave teachers. Um, so one group asked whether we should fund research that looks to eliminate 21 chromosome trisomy, meaning which you mostly know as Down syndrome. So this is a project that kicked off a couple of years ago and gaining traction really fast. So this was one thing, and another one because it was really related to most of the students have come from ranching families, so they asked whether we should use CRISPR to alter cows' coats from thick ones to slick ones as it becomes way more hotter in Wyoming. Everyone knows that. No one talks about why. So, that was another aspect. So, and teachers design a population dynamics model with social aspects impacting them. So here's kind of to show you the flow how we did that. So first, teachers kind of built a paper pencil model, as research shows that to support computational modeling, paper pencil model can be a good thing. And then they also mapped here some of the social and ethical aspects of the issue. Uh, in this case, it was whether we should fund the 21 chromosome trisomy issue. This is uh, an example of a model, a target model the teachers designed by themselves. It took them some time, and but I think it's even if you find this model a little bit inaccurate, you might find that uh, for teachers who were just introduced to Sage Modeler and to the whole idea of systems thinking and systems dynamic. This is quite nice. And what they are planning to do is to not to get their students to start modeling from scratch, but to give them just a backbone, which will move from a diploid to haploid and so on. And they wanted to see how the CRISPR like this is the CRISPR technology. If you can see, oops, my cursor uh, will impact the flow, the dynamic population, uh, and the population of adults with karyotype that has one additional chromosome. Here they just added some of, you can think of socio-scientific aspects. Again, also challenging to turn those some of those aspects to variables that are measured. So procedure, affordability, governmental regulations, and something that perhaps will affect the governmental population would be the public pressure for freedom, the way they call that. Um, so that's those are some of the artifacts, and this is just how they before writing, how they started to share how they are going to build the unit, and you can see the modeling, the iterative nature that they integrated into the unit. So you have they thought, oh, okay, after I'm going to teach about meiosis, I'm going to integrate initial model, and then after I'm talking about a non-disjunction events and non-typical karyotypes, oh, I'm going to do a first model revision for the students after I'm going to introduce CRISPR. So we have the scientific concepts, and the modeling is kind of interwoven into those as an iterative process. And finally, we'll talk more about they will consider all the social and ethical aspects and will revise their final model. So next steps is going into the classroom, observe teachers' implementation. That will include a screencast of students while they are building their model, collecting pre and post questionnaires from students, and interviewing students and teachers as well. So that will happen in 2 weeks. But that's uh, that's the first phase, I would say, that I'm presenting to you about our design-based research. And thank you for listening. And I will be happy to answer any questions or any insights or suggestions because this is a work in progress. So thank you very much.
Great. Thank you so much, Samuel. It's a really interesting presentation. And uh, since I don't live too far away from Wyoming in the global scale, I just wanted to give people a sense. You know, Emil mentioned that Wyoming is very rural. I think that's an understatement. So to give you a sense, Wyoming has just, I believe, just over 2 people per square kilometer across the state. I live in a desert, New Mexico, and we have 3 times as many people in terms of population density. So just to put that in perspective. So questions, Kim, go take it away.
I love this project. I love the focus on these kinds of highly controversial questions where systems thinking can really help a lot. Can you give us a quick glimpse as to what you're going to ask on the pre and post test survey questionnaire?
Yeah. So what we are asking is basically we want to measure the SSI reasoning, and therefore we are basing our questionnaire. We just tweaked the context a little bit from the already validated tool developed by Sadler and colleagues about SSI reasoning. So we just tweaked the the context to be more related to Wyoming. Um, so we already are using a validated tool and also a validated tool about attitudes towards SSI and those kinds of things. That was also developed by Sadler's group. Yeah, so because of the time crunch, just going through validity, reliability checks, and all of that, that was and I don't have a large group of people, so we went with already kind of validated tools that are out there.
What kinds
Reg
of questions are on the tool? Just
so yeah, Thanks. So some of the question I'll be happy to share it with you. So we give the students, also the teachers, but we for the teachers we made it a little bit more complex. So you give the students kind of a paragraph. It talks about um, fracking in Wyoming, so not something that is related to what they are doing, and about the debate and the controversies about that. And then we ask them questions regarding the paragraph, like why do you think they disagree? Do you think they would ever reach kind of a middle ground? Why do you think so? Those kinds of questions. So it's highly open-ended.
Thank you. That's very interesting.
In addition, we also look another artifact we're going to measure. So we didn't know that, but all the teachers agreed because, the summative assessment of that assessment or evaluation would be like a letter to the legislator in which they need to recommend their policy. So we'll also analyze them, and we are interested to see how or whether at all they use their models to make a kind of a policy decision and recommendation, whether that plays any part in that. We hope that it will, and then hopefully it will make the case that, oh, we can integrate modeling and systems thinking to SSI context and operationalize this. Here is a great way to operationalize systems thinking in the context of SSI. Hopefully, we don't know.
Emil, how do you think your teacher attitudes would be different, possibly, if you were working with, say, government social studies teachers instead of biology and chemistry teachers?
Wow, thank you for the question, Don. So my colleague and I in social studies, we try to come to kind of get this cohort of social study teachers and science teachers together. And so far, it did not go so well. There's a really difference, I guess, in political views and openness, I would say, between the social studies, again, the ones we reached out to, and social studies teachers in Wyoming and science teachers. It's that was a challenge. I don't know if it answers your question, but it's something we actually attempted. Like I reached out to my social study professor at the College of Ed, and she was very happy to cooperate, but um, it was kind of we won't stop trying, but it was a hard bump with some of the teachers, the social studies.
Yeah. Kim, I'm going to ask you just to hold your question for a moment. So we're going to be transitioning here from the presentations to the networking lounge. So I think we can continue some of these conversations. Um, just again, let me pause my recording and restart. Gaye.